Okay, so in this course, we try to cover all the aspects of wireless communication. So from the very basics of wireless communication to the simulation and some 5G communication aspect. And beyond that, we have also included some provision for MATLAB coding. And we are trying our best to give all the available resources as more as we can to the participants. So first lecture will be delivered by me, and next lecture, here we have an exchange. Next lecture will be delivered by Professor Sudhan Vanji from ISC Bangalore. Then we have another lecture on optimization of wireless network from Dr. Nishant Gupta, that he is from Linköping University. And next we have some big experts in the wireless domain, Dr. Aryan Kaushik and Dr. Vanjashin from Sussex University, UK and Korea respectively. Then we have also added some expert session from the MATLAB experts who will deliver you how to model the 5G network on MATLAB simulations. Then we have another expert on wireless channel, Dr. Kishore Ingle from VIT Vellore. Lastly, we are having Dr. Samiro Gyan from University of Moratuva, Sri Lanka. So overall, we try to cover all the aspects of wireless communication. And last day, we will have a validity session at 3:30. So without any delay, let's start our first lecture. So my lecture will be based on wireless evolution and technological advancement that that is started from back in 1860s to the 2024. So in between, if you have any query, you can ask me and you can interrupt me as well. So let's start. So this session will cover all the wireless evolvement that has been grown from back in 1890s to the 2024. Yeah, as a telecom operator or as a user, what we see at the communication end is this scenario where we have a mobile and we try to communicate to the network via base station. So this is what we see as a mobile user, but a lot more exists beyond that. So this is a core network which is connected to the base station and cannot be seen to a regular user, and hence this is what lies beyond our eyes. Overall, we can say the whole communication framework as is shown in this figure can be partitioned into two sub-frameworks. First one is wireless network where a user is connected to the base station, and a core network which is to deliver services to the users that is connected to the user via base station. So core network is nothing but your intended network. For example, if you request to access a YouTube video, so this core network can be seen as a server where all the videos are being decided, and on demand it can provide you service of such videos. So one by one, let's have a look what happens within this wireless network and what happens within this radio access network. So first, starting with the wireless network. So first of all, building wireless intuition, how the information is being transmitted from one end to the another, especially between this wireless channel from the base station to the user. This is one typical scenario where a mobile user wants to access some of the information, which is usually being transmitted in the form of electromagnetic signals, where base station transmits some power PT, and all your information is being transmitted in the form of electromagnetic wave that is being transmitted with power PT. But as a user, we don't get all the power. and some of the power being degraded. So here, though we have transmitted some power PT, a fraction of that is available to the end user. So all the information that is being transmitted, though we have transmitted power PT, that being shaded away within the environment, and we get some alpha times of PT. Alpha is obviously lesser than the unity factor 1. So alpha is always less than 1. This is due to the environmental degradation. So whenever we try to transmit something from the base station, it experiences some sort of degradation and impairment. So first impairment is the distance. So it depends on the distance how much power will be accessed to the end user. Also, it depends on time. For example, as shown in this figure, the power is being delivered to the user via different medias. So not only one component, a user receives different components, and number of components depend on the number of entities presented in the environment. So in this case, there are 3 entities and the user gets the power from the reflected part from all these entities. These entities can be more than 3, more than 5, and less than 3 as well. So it depends on the time. So depends on the position of building, depends on the position of car, and also it depends on the relative velocity of the user. In short, our wireless channel between the transmitter and the receiver and the user is highly dependent on distance, dependent on time, as well as it depends on operating velocity or the velocity of the user as well as the scenario. Another impairment or another big task to handle with in communication is the interference. Because as shown in this figure, not only one user is being served at a time. In this figure, 2 users are being served by 2 different base stations. So one base station TX1 is intended to serve user 1, which is shown by black color arrow here. Another base station at the same time is trying to serve another user, that is receiver 2, which is being transmitted by base station 2. But in order to serve their respective user, transmitter 1 creates unintentional interference to the user 2. Similarly, transmitter 2 creates unintentional interference towards the user 1, which is shown as blue here. So red here. So blue one is the desired power from the desired base station, and red one is the unintentional power or interference power from the unintentional base stations. So this is another issue which need to be tackled to assure a qualitative communication. So these are some issues which would be known to the graduates, undergraduates. So I just summarized to gain some understanding out of it. Now coming to the communication matrices. So it is highly desired that the blue portion should be, or the blue power should be as large as possible as compared to the red power. And in communication, it is known as one of the best known metric, signal to interference and noise ratio. So whatever desired comes at the numerator, and all the undesired power comes at the denominator. So in the undesired power, among the undesired power, it is always interference, as well as some noise power can also appear in denominator. So our intuition is to have more desired power as compared to the undesired power. And this SINR, signal to interference and noise ratio, should be as more as possible in order to have better signal conditions. Now, just to summarize what is required at this end. So first one, this is the very well known equation that is known as Shannon-Hartley capacity theorem and capacity equation, where the channel capacity depends on the channel condition, that is signal to interference and noise. So the better the SINR, the higher the data rate it can achieve. Also, the data rate depends on the available or assigned bandwidth to the user. And nowadays, there is one more factor. Not only one transmission link, there can exist multiple transmission link between the transmitter and receiver due to the coexistence of multiple antennas. So at the transmitter end as well as at the receiver end, we have multiple antennas. So multiple antennas create multiple channels between the user and transmitter. Therefore, therefore increases the data rate that is to be transmitted from the transmitter to the receiver. This is one aspect. This is the channel capacity theorem. So I request you to understand or remember this throughout the whole presentation. So this is the backbone and base of the wireless communication. Another essential aspects are summarized here. So how we can avoid the interference? Interference can be avoided to assure orthogonality among different users. For example, coming back to the previous slide, if transmitter 1 transmit at one time, transmitter 2 transmit at another time. So that creates some orthogonality between user in terms of time. Similarly, we can also create orthogonality in terms of frequency. If transmitter 1 is transmitting at some frequency f1, transmitter 2 can use some other frequency so that the interference cannot take place. So at the same time and the same frequency leads to the interference. Just to assure the interference, we need to provide the orthogonality among the users. Next one important aspect is the more the available bandwidth for the user, the more the data rate it could be he or she could achieve. So as shown in the channel capacity theorem, increasing the bandwidth will assure and lead to the more data rate. Next is transmitting antennas. As we keep on increasing the number of antennas, it will give rise to the more data rate. And this notion is known as MIMO. Multiple antennas at the transmitter and multiple antennas at the receiver will lead to MIMO, multiple input, multiple output communication. Next is another essential aspect in wireless communication, channel variation. How to get rid of the channel variations? Because if the channels are very high, even though we can transmit more and more information, there are chances that we have transmitted some information and we are getting some other information there due to some error that has been introduced while the transmission takes place. So in order to assure error-free transmission, we use some sort of coding. For example, instead of 1, we transmit 111 triple 1. Instead of 0, we transmit 000 triple 0, so that even if one of the digit comes in received in error, we can decide based on the majority that 0 has been transmitted, even if we are receiving 100. So based on the majority rule, we can decide that 0 has been transmitted or 1 has been transmitted. So channel coding is another aspect. Now coming to the another aspect, which is though with higher moving to the toward the higher frequency band, for example from microwave to the millimeter wave, gives you more bandwidth, but higher frequency bands attenuate very fast. So the attenuation experienced by the higher frequency is greater as compared to the attenuation experienced by lower frequencies. Next is spectral reutilization. So since we know that the spectrum is limited, so if one frequency band is utilized at one location, we can reuse some frequency band and at some other location. This is known as the concept of cellular concept, and which is being introduced by Bell Labs back in 1960s. Next is, and last one is, multipath component can be manipulated by controlling their phases. So as shown in this figure here, different component reaches at the receiver and experience different phasing, different delay and phase. So we can also utilize these phases at the transmitter end. We can we can additionally assign some sort of phase so that at the receiver, the phases can be utilized to nullify the interference or to maximize the addition of those phases at the receiver. So we will get all the aspects one by one. So this slide only summarizes the requisite and enhancement in the wireless communication. Now coming to the performance matrices, what are the well-known wireless communication matrices? First one is bit error rate. Bit error rate is the measure of how much fraction of the total transmitted bits are received in error as compared to the total number of bits transmitted. For example, if we are receiving 100 bits in error out of transmitted 1000 bits. That means 100 divided by 1000. 10% of the transmission is being occurred in error. So bit error rate is 0.1 or 10%. Next one is another metric is wireless communication coverage probability. Coverage probability is a matrix that decides how much time the user is in coverage, or what are the chances and or probability that the user is in coverage out of the all the available time instances. Next is the data rate or throughput. So data rate or throughput is nothing but the capacity that is being assigned to the per user. So there are different measures to increase this data rate. Either we can increase SINR, or we can increase the available bandwidth per user, or we can increase the number of antennas. So I think we have covered some of the basic and essential aspect of wireless communication. Now we can dive into the journey of wireless communication from the very basics or first transmission towards the third generation. So first we will cover the journey from 1895 to 2000, and then we cover what are the advances being occurred after 2000. So any of you is having any doubt so far?
Yes, sir. This coverage probability, does it mean outage probability?
Yeah, coverage probability is directly connected to outage probability. These are two different terms. One minus coverage probability means the user is in outage.
Outage.
Yeah. Any more doubt? Okay. So I think we can go ahead towards the journey of wireless communication. So how it has been started. So this is the case, or in this figure we are depicted that how the communication has been started back in pre-industrial age. The communication has been done through the some signaling known as fire, or through the home pigeons. Those could be used to transmit some sort of attention signals, or we can say some sort of small mailing through the pigeons. Next, it was first in 1895 when Marconi demonstrated first radio transmission communication through Isle of Wight. So the first communication was established between Isle of Wight and tugboat, which is 18 miles away. So first communication has been occurred within a very minimal distance of 18 miles. But soon after 5 years, in 1901, Marconi managed to transmit the Morse code from one end to the another, that is from UK to Canada, across the Atlantic Ocean. So that was the first time the communication has been occurred back in more than 100 years ago. And at that time, there was some enhancement being occurred in terms of VLSI circuits. So at the same time, Lee Forrest invented triode, which is the another breakthrough in making circuitry or circuit designs for the communication purposes. At that time, because the equipment size was very large, the communication equipment were popular for only for safety and sea vehicles. So some evolvement have been occurred from time to time, and after 50 years we get a way how we can reuse the frequency, how we can allocate frequency to different regions. So coming to this is about the communication system available for the general public. So as we keep on increasing the availability of communication to the general public, so we need to make efficient use of the available spectrum, because the number of users are very large when we connect the general public. So before that, the communication was only available to the police and administration. So the major breakthrough was the introduction of cellular concept, where hexagonal cells, the all the available region has been divided into hexagonal cells, and after each periodic pattern we were reusing the frequency bands, assuring that the interference could be minimized. That is known as the notion of cellular reuse, and was very famous and proposed by Bell Labs in 1960s and 70s. Soon after that, after 10 to 12 years, what happens? The first generation of communication system came into the picture. First of all, the first generation was limited to the voice transmission. No data transmission could take place. And also, different region, different countries were in a hurry to make their own standards so that they could lead this telecom industry. So each and every nation wants to create their own standard. For example, this lead to the creation of different standards among the different corners of the globe. First one is analog mobile phone system that has been initiated in America. So this is one standard in the first generation of wireless communication system. Another standard was total access communication system that is became popular in Europe region. Another standard in Europe region was Nordic Mobile Telecommunication (NMT), and some other standards were became very popular. Out of these, one is Japan Total Access Communication. So roughly, if we have a frequency using a spectrum of first generation communication system, it is AMPS, that is illustrated before, TACS, NMT, and NTT. So as you can see, different part of the globe were using different frequency band for uplink and downlink. So AMPS and TACS, which became very popular in the second generation, third generation, and so on. So they used 824 to 849 megahertz spectrum. So within this spectrum, 849 minus 824, this gives you a total band of 25 megahertz. So per user, in order to accommodate each and every user, we almost require 30 kilohertz spectrum. So to accommodate one call between two users, we need to assign 30 kilohertz band to each and every user. So we are having total availability of 25 megahertz, and the channel spacing for per call utilization is 30 kilohertz. So how much band we can accommodate? 849 minus 824 equals to 25 megahertz divided by 30 kilohertz. That will give you 832 users could be accommodated in this band in the first generation for uplink and downlink. So similarly, you can make another calculations as well. So I will share this slide for you. You can make the calculations later. Roughly, you can estimate the number of channels or number of users that could be accommodated in the very first generation was very limited to thousand or hundreds only. So to make some betterments, second generation come into the picture. So as we have discussed that first generation was analog only, and we could only support the voice communication. So in the second generation, we have switched from analog to the digital communication system. So coming to the digital gives another advantages. First of all, being digital, the we can now apply some uh, better signal processing aspects. Another advantages is we can now use codes because the information or voice can be the data can be represented in terms of bits. We can now apply some sort of coding to it, and also there are some other advantages as well because digital communication is spectrally efficient to transmit. So in the second generation, the biggest change was to move from analog to digital, and this gives rise to the representing the information in terms of bits and messages. So another breakthrough or feature was SMS. We could be able to transfer SMS between the users. So another biggest change was Edge that introduced 8 PSK modulation. Stands for enhanced data rate for GSM evolution. So we will get to know about all these things, what happens, and what are the advancement have been occurred in the next subsequent slides. This is an overview of the second generation communication system. The bands are more or less same. So again, IS 136, which has been earlier TSES. So it is again using 824 to 849 bands, but now the information is being transmitted in the form of digital bits. Also, as we can now represent data in terms of bits, so we can now use equalizer to get rid of channel impairments. Channel access scheme is another big advancement. So earlier in the very first generation, we used to have frequency division multiple access to orthogonalize different users. Now we can use TDMA. That means we can now differentiate different users in terms of transmitted times. So TDMA is introduced in second generation. So this is the whole graph how this standardization has been worked. As I mentioned earlier, different nations and different countries used to have different standards for their own. So efforts by the end of 2000, 1990s, 1980s, efforts were made to standardize the things so that irrespective of your location across the globe, you can use same sort of standardization and your mobile could work everywhere. So if a mobile could be used anywhere or any corner of the world, you need to follow the same standards. So to make some standards, some organization were came into the come into the picture, and most popular of them is 3GPP or Third Generation Partnership Project. So this is an organization under which, or we can say this is an umbrella under which all the standards are being formed and frozen, so that and all other nation uses those standards. So before that, you can see in the second generation you have different standards. Some of them came from US, some of them came from Europe, and some of them came from other parts of the nation. There, for example, Japan has its own NMT standard. So 2.2G becomes 2.5G, where in 2.5G we introduce high-speed circuit switch data, GPRS, Edge. So we will discuss about what are these HSCSD, GPRS. And finally, in 2000, we came to have a standardization in terms of 3GPP. Again, we could not lead to a single standard. We had to have two standards in picture: 3GPP and 3GPP2. Uh, these are organization working on two different standards. Roughly, one gives rise to the CDMA transmission protocol and one from the TDMA transmission protocol. So we will have a look at this. So this was roughly the journey from 1895 to the 2000. Now let's have a look what happens after that. So major and drastical changes have been adopted after 2000 due to the commencement of third generation, fourth generation, and 5G communication system. Now let's have a look onto that. So any doubt or query so far? Okay. If no, so I think we can go ahead. So if as we are talking about the standardization, so what are the standardization bodies internationally recognized internationally to create standards for wireless communication system are summarized here. First one is ITU, that is known as International Telecommunication Union. It's a specialized agency that works in United Nations. It is prominent agency for setting up standards on radio communication. Majorly, there are three subparts in this organization. ITUR, which takes care of radio communication recommendation, and next is ITUT, that takes care of standardization sector in telecommunication. Last one is the development sector of ITU, that is known as ITUD. Next, coming to the 3GPP, as I told earlier, 3GPP is the most recognized organization in the or umbrella. I can say umbrella. ITU is also one of the most recognized organization. ITU is an umbrella where we sit together and we try to formulate some standards. For example, after each 4 year, we used to have a World Radio Conference, WRC. So last one has been done in 2019 and 2023 and so on. It is a periodic. So we sit together periodically and we try to formulate different standards for previous and next generations. Other bodies are IEEE is one body, ETSI. In India, especially, we are having IETF, Internet Engineering Task Force, and IMT. First, let me discuss about what is IMT. IMT is an umbrella which comes under ITU. In IMT, we used to formulate some sort of recommendation. Means what are the requirement of next generation and how these requirements could be fulfilled. For example, IMT 2000, which has been developed in the year 2000, illustrates what are the prerequisites of third generation. Next, in 2010, we had IMT advanced, means requisites for fourth generation communication, and then that came into the picture in 2010. Again in 2020, IMT 2020 uh, uh, confines the recommendations for fifth generation communication system, and the recommendation for sixth generation have already been uh, highlighted. So in IMT 2020 2030, we can get those recommendations required for sixth generation communication system. And now coming back to the 3GPP, 3GPP regularly publish an article known as releases. So in different releases, and each subsequent release, it tried to get or formulate or freeze some sort of standardization procedure how we can achieve that communication between user, and what are the frequency bands that could be used in different parts of the globe, so for the harmonization purposes. Also, what could be the pattern of transmission frame. All such details and antenna specification and all other standardization procedure comes into the picture by release. So first release has been first release was the day we try to formulate some sort of global standardization. We get some releases coming periodically into the picture. So we are going to discuss about the third generation and fifth generation with the help of releases. Releases means what sort of standardization has been formulated so far, one by one, bit by bit, how this phenomena has been changed. So before that, let me remind you uh, what are the prerequisites of communication. Again, the intuition is to allow a user to get more and more data from the base station. So back in 1950s, 1960s, all the efforts are being made to allow a user to access more bandwidth, more number of antennas, and more number and better transmission channel scenario. So all the efforts being done from second generation, third generation, fourth generation, fifth generation, roughly we can say all the efforts are being done to increase any one of the aspects. Also, in parallel, we are trying to make efforts to make our codes very effective. The channel codes or correct error correcting codes would be very effective. So all the efforts are being in this line. Now coming back to the standardization purpose. So wireless evolution with the help of releases. So as we told earlier, releases are some document which publish periodically, time to time, under the umbrella of 3GPP. So this is how we can summarize all the releases. So first release was published in around in 1996, then 97, 98, 99, 2000, and periodically we get releases. So roughly we can note down, and as we can see, up to release 99, we can see it all the releases and document covers aspects related to second generation, second G or 2G. And then in the year 2000, we started working on 3G, and so as the release 2000, that is renamed as release 4, release 2002 named as release 5, and After that, all the releases subsequently known as release 5, 6, 7, 8, 9, 10, 11, and so on. So up to release 4 to release 7, all the aspects and standardization details are listed belong to third generation communication system. Next, we have release 8, 9, 10, 11 up to release 14 that belong or covers all the aspects related to the fourth generation communication system. Beyond that, we are having releases 15, 16, 17, 18. Those cover all the aspects related to the fifth generation communication system. So any doubt with the what is a release, what is 3GPP, how some standardizations are being done? Anyone? Okay. So as I told earlier, all such releases and efforts are being, the motive is only two. First motive is to allow a user to use more and more bandwidth, more and more resources, better and better data rate, and better channel condition, increasing number of antennas. And second motive is to have a global standardization and technological harmony so that a user could be allowed to move from one location to another location and there could not be any protocol breach or any difference in the use protocol globally. Okay. So phase 1, phase 2, different enhancements has been made in 1992. What are the key advancement have been made? So second generation, which was launched in Finland in 1991. So first major breakthrough was in the, as compared to the first generation, second generation was analog to digital transformation. Next is, now since we are working in digital domain, we can now represent all the information in terms of packet and frames. Next one is error correction and detection capabilities can now be added because the data has been uh, represented in terms of bits. And key features are bandwidth is still smaller. Per user bandwidth is so 200 kilohertz bandwidth was allocated to 8 users. So more or less per user bandwidth is almost the same, around 30 kilohertz only. Next major breakthrough was we have now shifted from FDMA to TDMA, which is more efficient. Again, the utilized operating frequency is 824 to 849 megahertz only. Next, the data rate is still very less, which is around 9.6 or 14.4 kbps. So these are some features of first generation or second generation. Now coming to the betterment, which has been held in the 2.5 generation. So release 96, 97, 98, 99 made some efforts to increase this data rate. So as I told earlier, efforts were made to assign more and more resources. So in 2.5G, what happened? They give rise to the some high-speed circuit switch data, which is acronym as HSCSD, which allows one user to use 4 slots. So one user 4 slots, and each slot can give you 14.4 kbps speed. Means now 4 slots are assigned for one user. That means a user can have 14.4 into 4 equals to 57.6 kbps data. So this is nothing but allowing a user to use more resources. And next enhancement was circuit switching has been adopted. So let's have a quick overview of what is the circuit switching and packet switching. A packet switching is to transmit a data in the queue where one packet, each subsequent packet follow the same path through all the routers. So that is very nice in terms of error because you cannot detect any packet out of order. But coming to the circuit switch, as compared to the packet switch, in the circuit switch, the data could be allowed to follow any path through each of the routers. So all the available space can be efficiently utilized. And now the data rate has been increased because the packets can traverse anywhere and the destination is same. So you can receive the packet out of order, but the data rate or the arrival time of the packet at the destination becomes very smaller. So circuit switching is better in terms of data rate, and packet switching is better in terms of error in terms of error, because you cannot get any packet out of the order. So usually we want to establish a voice call, so voice could not be break. The data can be, it can may come after 1 second, 2 second. So for data transmission we use packet switching, where we want more data rate. And for voice switching we used for voice transmission we use circuit switching. So here reliability, we want more reliable system and less erroneous. Next, subsequent releases introduce GPRS, General Packet Radio Service. So this is based on the packet switching, which drastically increases the data rate from what is called 14.4 or 57. That is has been increased up to 150 kbps, and it also relaxes some sort of error correction capabilities. Now, next come to the edge. Edge stands for enhanced data rate for GSM evolution. So whatever GSM has been used, now in the enhanced data rate, we can now use 8 PSK as compared to the QPSK. When we transmit 8 PSK instead of 2 symbols, in the same time we can now transmit 3 symbols. So as I told again and again, the intuition is to allow a user to access more and more data rate, or to access more and more resources, and to have more and more better transmission capabilities. So here, instead of QPSK, we are transmitting 8 PSK, and this increases the data rate by a factor of 50%. Now coming to the third generation. In the third, moving from second generation to the third generation, the major breakthrough was in terms of multiple access technique. In the first generation, we used FDMA. In the second generation, we used TDMA. In the third generation, we are not using even TDMA or FDMA. Obviously, in backend, the frequency bands are divided into slots, but at the front end, we are using CDMA. That means you can transmit on the same frequency on the same at the same time, and still you will not experience any sort of interference, because now multiple users are being orthogonalized in terms of code. So different users are being assigned same frequency, same time, but codes are different. That allows them to transmit more and more data, and the bandwidth has drastically increased from 200 kbps for 8 users to 5 megahertz. So this is obviously for more number of multiple users, but we will see in the later section that the data rate has been drastically increased. So release 2000. Let me have a couple of minutes to look at the nomenclature of this release. Release 2000 has different reasoning to assign this name. Release 2000, first reason was that it has came into the picture into the year 2000. Next reason is why we use 2000 term here. The data rate has now been increased up to 2000 kbps. Next reason is, and the last reason is, that we are now using 2000 megahertz operating frequency. That means we are now working on 2 gigahertz frequency band. In the third generation, we have shifted from 800 megahertz to 2000 megahertz, that is 2 GB or 2 gigahertz frequency band, around 2 gigahertz frequency band. So as we increase the bandwidth drastically, in the time domain, we are shrinking in the same proportion. And now we can use one receiver that is known as rake receiver. Rake receiver is nothing but a provision to use different multipaths. So we can now combine different multipath efficiently. So again, we have now moved from the different frequency FR3, FR4 to FR1. Frequency reuse 1, frequency reuse 2, frequency 3 reuse 4 to we have shifted frequency reuse 1. That means each and every cell can now use all the frequency available frequency bands. So don't confuse with FR here and FR in the subsequent slide. FR in the subsequent slide is known as frequency range. In this slide, FR is known as frequency reuse. So these are some advancement in release 2000. Coming to release 2002, 6, to 2, 4, and 7. That means release 5, 6, and 7. HSDPA. HSDPA, that is known as high speed downlink packet access. This is another provision to allow a user to use multiple resources. So we will summarize what are the HSDPAs, and HSUPAs are also available for uplink transmission, that is high speed uplink packet access, known as HSUPA. High speed downlink packet access is known as HSDPA. So these are some other efficient utilization of resources for downlink transmission and uplink transmission. Again, the motive is to allow user to access more and more resources and to provide them to experience low and low user mobility. Now, another breakthrough is we can now having sufficient computation capability at the user as well as at the transmission end. So we can now accommodate higher order modulation. In the previous generation, we have moved from 2 PSK to 8 PSK. Now again, we are increasing the modulation order up to 16 QAM. That means three bits per symbol to we are now increasing up to 4 bits per symbol. Again, we are having channel aware scheduling. So we will transmit 4 bits per symbol only when the channel conditions are good. If the channel conditions are bad, we can transmit less number of symbols, or we can switch from 16 QAM to 4 QAM or QPSK up to PSK if the channel conditions are very bad. And we keep on enhancing in terms of data rate and latency. Now coming to the fourth generation of communication system. In the fourth generation of communication system, which again provide us different provision to use efficient channel access mechanism as well as simultaneous transmission, simultaneous multi-transmission access from base station to the user and vice versa is also true. So two major breakthrough occurred in terms of fourth generation. First one is we introduced MIMO. Now instead of one channel that has been created between user and base station, we can now create 2 channels and 4 channels and so on. So as the generations are keep on increasing, we are increasing this number. So at background, the MIMO order is being increased. So from 2 cross 2, we are now moving towards 4 cross 4, and then 8 cross 8, 16 cross 16, 64 cross 64, and so on. So we are keep on increasing the number of antennas at the transmitter as well as at the receiver. So first major breakthrough from third generation to the fourth generation. Obviously, the first release of fourth generation was the release 8, and that is known as uh, the for two major breakthrough. First one is MIMO, and second one is the multiple access techniques now become OFDMA. OFDMA stands for orthogonal frequency multiple access, that allows the overlapping of subsequent frequency bands. That means we are now having an efficient way of utilizing operating frequencies. And again, we parallelly we are making significant efforts to again and again increase this HSDPA. HSDPA means more and more efficient methods for high speed downlink packet access, and in the at the very first time in release 9 we have another version of HSDPA, that means HSUPA, that allows the high speed packet transmission in the uplink direction as well. Again, some other efficient method have been proposed in the subsequent releases, that is known as carrier aggregation, intercell interference coordination, software organized network, and so on. So we will discuss all these things. Next is release 10, which is again connected to the fourth generation of communication system. 10 and 11 combinedly make some enhancement. For example, first one is it allows carrier aggregation. So if one carrier is not sufficient for the data transmission of user, you can assign 2 carriers. Earlier in 2G, what we have to do, we would have to assign multiple slots, 4 times slot per user. Now we are assigning 2 bands per user, so 2 band, 3 band, Up to 5 band we can assign per user. That means again we are making efforts to assign more resources to one user. So up to 5 carrier we can assign to single user so that he or she may get better and better data rate. Now again in the release 10 and 11 we had a provision to use 4 cross 4 MIMO. And in the downlink we can use 8 cross 8 MIMO. Carrier aggregation enhancement. Again, next one is COMP, Coordinated Multi-Point Access Scheme has been introduced in release 11. So these are some enhancements that has been made generations to generations and release to release. Now coming to the release 12, 13 and 14. 12, 13 has combinedly provided the provision and lead to the heterogeneous cell network. Dual connection provision has been given. So dual connection means a user can now connect it to the multiple base stations at the same time. That gives rise to the dual connection. Better positioning methods have been given there so that the beamforming can be achieved. So beamforming is another aspect which give you better and better and efficient transmission rate. Next and biggest breakthrough is now you can transfer your voice and through the data communication channel that is known as voice over LTE. So you do not need to have a uh, dedicated core radio area network for voice. That means in the previous generations you used to have different paths for voice and different paths for data. Now you can transmit your voice on the same path where the data flows, because now you can convert your voice into the data and that goes onto the LTE network, and which is why it is known as voice over LTE. And this is again more emphasis is given to the energy efficiency. So by the end of 2010, some provisions and guidelines have been created to have an efficient methods for wireless communication. So now in the fifth generation and onwards, we will have to look at the energy aspects of communication systems as well. So this is the journey from 2000 to 2020, 2000, 2000 to 2000, roughly 2010. What has been occurred in these 10 to 12 years from the perspective of wireless communication. So this was about third generation and fourth generation and other uh, uh, related and essential aspects. So is there any doubt so far? Because we have almost covered all the aspects of third generation, second generation, and fourth generation. We have only left with the releases related to fifth generations here. Any doubt so far? So I hope you are listening it very well and the slides are understandable to you. Okay, so let me go ahead with the fifth generation of communication system. So these releases 15, 16, 17, and 18. You can see here the releases are available for fifth generation communication system before the end of 2020. So already we have some standardization procedure and standards available, protocols available to use the fifth generation communication system. So first and biggest change that has been observed here is the now we have a different radio network. This is known as new radio. 5G radio network is known as new radio or 5G NR. And again, the definition of 5G is very much different from the third generation, fourth generation communication systems. And again, the 5G is different from different perspective as compared to the previous generation. First one is the number of devices will drastically increase. The connected devices in the net to the network will drastically increase, and the bandwidth and data rate requirement is very vast, because in the 5G you will connect your very smaller devices, IoT devices, to the very high critical devices. For example, regular communication. So it will support from a very small smartwatch to the critical vehicular communication systems. And in terms of number of devices, the devices will drastically increase. In terms of flexibility, so each and every device will be efficiently and seamlessly connected to the network. This is the vision. Now coming to the RAN requirements. RAN requirements are being open. That means no close or fixed protocol will be available. So we are now moving from the agency specific to the open standards. So these are some major breakthrough and requirement of 5G. Now coming to have a look at the 5G architecture. Before that, let me summarize you to the HSPA evolution. Sorry, I forgot to mention here. This figure has not been built by me, and I will provide one reference for it. So roughly, so the high-speed packet access in the uplink and downlink directions are summarized here. First, you can see here. Look at this diagram. Now, from 16 QM, we are now increasing, and in here we have increased up to 64 QM. Coming to the carrier aggregation, instead, if one carrier is not sufficient, you can allow one user to use different carriers, two carriers in the uplink, two carriers in the downlink, up to four carriers in the downlink, and so on. So with the increase evolvement in the release from release 5, 6, 7, 8 up to 10, you can now have different evolutions. Dual connectivity features are there. So these all are comes under the category of HSPA evolution, high speed packet access evolution. So with this, we have almost covered all the aspects related to this wireless network. So all of what happens between the user and base station have been covered, except 5G. 5G I will cover in bigger detail. So most of the critical aspect I have discussed obviously with 5G. So wireless network and their essential aspects we have already gone through. Now coming to the radio access network. Again, if you have any query, you can ask me. You can interrupt me in between.
Sir, I request you to explain some basics about HSPA.
Yeah. HSPA is not one technology. HSPA is a technology. HSPA covers different technologies, high speed packet access evolution. So within which we cover different aspects. First one is number of resources that could be assigned to a user. So earlier we did not have a provision to use multiple resources. Now we can assign different resources to multiple users. That is known as uh, carrier aggregation. So instead of one carrier, you can now assign different multiple carriers, 2, 4, 8, and so on. Okay, so up to 5 we can assign as per the release standard frozen. Next is the utilized QAM. Utilize this spectre you can see here. So instead of QAM, we can use 64 QAM. You can use QPSK. It depends on the channel condition. If a channel condition is very bad and that cannot afford this closely located constellation points, so you can shift up to 16 QM. Even if the channel conditions are worst, up to 64 QM, you can use QPSK. This has been covered by HSP evolution. Another one is that it is uh, it is not always true that a base station can fulfill all the requirement of a base station of a user. For example, if the connectivity is very poor, you can ask two base stations simultaneously to serve you. So that provision has been again provided by release 8 or 9. I'm not remember, but it all such enhancement comes under the category of HSPA. So that gives your answer.
Thank you, sir.
Yeah. To the radio access network part. So till this slide, we have seen what are the advancements and As I told earlier, the RAN has also been keep on evolving with respect to the evolvement made at the front end. So in the very first generation, this is known as GSM RAN. Or in the second generation it is known as GSM because at the front end, wireless end, we are using GSM. In the 2.5 generation, we are using or digital packet switching to the circuit switching. So it can now cover GSM Edge RAN, GE RAN. Third generation RAN was known as UTRAN, UMTS, or Universal Terrestrial Radio Access Network. And next, in the fourth generation, we are having EUTRAN, Enhanced Universal Terrestrial Radio Access Network. So, what it consists? A user equipment can be a mobile, smartphone, tablet, your laptop, anything. Core network is a server which consists of all your information which is being requested. For example, as I given as an example to access a video at the YouTube server. So you can request your radio network. Radio network will connect you the core network, which is YouTube server in this case. And radio network, radio access network covers base station, your transmission antennas, E node B, G node B are the names for base station only, base transceiver receiver station only, but in the different generations are being evolved. So this is one of the basic RAN architecture. At one antenna, what you can see at the base station, we could only see the antennas. But in addition to antennas, the base station also consists of this is for all your transmission or conversions. You can say this. You can also say this as a processor unit of station. Okay, so roughly these three are found at any cell site. The remote you to the antenna via coaxial cable, but coaxial cable itself experiences 2 dB attenuation. Therefore, now radio unit are coming closer to the antennas as to avoid such attenuations. And again, the baseband unit is at the bottom, which is connected to the antennas via some proprietary interfaces. This is one another important component of the transmitter remote radio unit, which is the so in the wireless in the wireless entity we cannot transmit the discrete signal. So we need to convert all the signals into the continuous one by using some sort of modulation. So before the real transmission, all the signals are converted back into the analog form, and at the receiver end, we perform the reverse of it. So as you can see here, before the transmission, all your digital messages are converted into the analog via using DAC, digital to analog converter. Then they are amplified and then transmitted to the space. Conversely, at the receiver end, it is being passed through the low noise amplifier and then converted to the converted back from analog to digital. So this is an overview of different RAN, radio access network. This is first generation RAN. This is second generation RAN. This is the 2.5 generation RAN. Okay. Look at the first generation RAN. There is the base station which is connected to the core network via your mobile is connected to the core network via base station. Base station is being controlled by MSC, that is Master Station Controller for Mobile Switching Center. GRAN, here at GRAN, you are at the bottom, user equipment, which is wirelessly connected to the base transceiver unit, and base transceiver unit is being controlled by base station controller. which controls base transceiver unit. And at the core network, you get the mobile switching center. And this used to carry your voice data. But in the second generation, you have also you need to also deal with the packet switching of your data. So in addition to this network, we get another provision to handle your packets. So GGSN and SGS, these are two units to, so this G stands for GPRS data network. So these two entities have been added up in addition to the GRAN network to handle your packets. So let me just introduce you one of the radio access network available in the second generation. So in the second generation, starting from the top, MS is the mobile station, that is your mobile that is wirelessly connected to the base station, base transceiver station via uh, wireless interface UM. So at the bottom side, you are just wirelessly connected to the BTS. BTS is nothing but base transceiver station. Base transceiver station is being controlled by BSC, base station control. So if you move from one base station, from one hexagon to another hexagon, all such operations are being handled by BSC. But if you move from again at the back end, each BSC is being controlled by MSC. So if you move within the vicinity of one MSC controller, there is no need of requesting another MSC. But if you are calling someone, let's say you are in the vicinity of one MSC, in the BSC which is controlled by one MSC, and you are calling someone. Let's say you are calling from Jalandhar to Mumbai, and in that case MSC will be different. So first your call will be transferred from BSC to your MSC, and your MSC will try to connect the MSC of your target user, and then his MSC will connect to the BTS of his MSC, and then this is how a connection is being established. Again, how someone can get your address with the help of these registers: digital locator register, home locator register. If you are in the vicinity of your home BSC and MSC, your address will be reside here, home location register. If you are in the vicinity of some other mobile station, that means your location will be residing in visitor location register of the new MSC where you are. These are some other boxes as well, which are very straightforward to know. EIR, Authentication Center, OMC, Operation and Maintenance Center. So these are nothing to do with the transmission. So this is roughly the idea how your call has been made, how base transceiver system is being controlled by BSC, and BSC is controlled by MSC, and different MSCs are connected interconnectedly in the core network. So this is how a full network is being made. Now, here is one example how the second generation communication system was done. As I told earlier, the second generation communication was based on the TDMA, time division multiple access. And the TDMA, what happens? So in the very first generation, we used to use these 800 and 900 frequency bands only. So from 892, 915 we used for uplink, and 935 to 960 we used for downlink. And per user bandwidth was, I think, roughly 200 kilohertz. So in the 200 kilohertz, we assigned this. And this, again, whenever we divide the whole frequency band into the number of chunks, so how much total number of channels we can create? If we divide 915 minus 890, that gives you roughly 25 megahertz band, and each transceiver channel takes 200 kilohertz band. So 25 megahertz divided by 200 kilohertz will give you around 124 or 125 channels. So 124 channels are available for uplink, 124 channels are available for downlink. But you cannot use such channels at all the times. You will assign some of the slots only. For example, a TDMA frames frame consists of 1, 2, 3, 4, 5, up to 8 slots. And in each slot, you are having different entities to be transmitted. Guard space to prevent delay, tail and synchronization symbol, and training symbols. Out of which you have only 57 bits here to be transmitted as data. So with this, we can make some calculations regarding the achievable data rate. So FDMA spectrum 25 megahertz for uplink, 25 for downlink, so that we can get 124 for uplink, 124 channels for downlink. Because okay, you can make some other calculations as well. Total separation is 935 minus 915. And frame duration, you can see here 4.615 millisecond. This is all the frame duration, which consists of 8 slots. And one slot duration is 4.615 divided by 8, which is equal to 546.5 microsecond. That means in this, if you assign only one of the slot out of this available 8 slot, in 4.165 millisecond, you are transmitting only 57 plus 57, that is equal to 114 bits in 4.615 milliseconds. So this is how you calculate your data rate. Any doubt in this? Okay, if not so. So this is a rough idea over how we connect your mobile to the base station in the second generation. Now coming to the next one. So these are evolution from second generation to 2.5 generation. So in the 2.5 generation, you get all the entities which are very similar except this. This is to handle the packet data rate transmission in the circuit switching scheme. So next is the third generation, then, that is known as universal terrestrial radio access network. So where you get a biggest change. Now the base transceiver system becomes node B, and your base station controller is known as RNC, that is radio network controller. In the fourth generation, you get UE, that is connected to the core network via UTRAN. That is universal terrestrial radio access network, that is connected to the wireless network UU, and the RAN network is connected to the core network via IU. So a few basic information are given here within the slide. We will share this slide for you. So UTRAN and site is here. So here, this is the user plane, which consists of a mobile and a SIM. This is the radio access network, and in the core network, you are having similar entities. For example, master station controller, HLR, home, but with different names. So this is UTRAN radio interface. As I told earlier, in the third generation, the multiple access techniques have been evolved from FDMA, TDMA to CDMA, where different users have been organized in terms of code. So for example, if you assign 1, 1 to one user, 1, -1 to another user, so these are orthogonal, user 1 and user 2. How? If you multiply 1, 1 with 1, -1, so first 1 and 1 will give you +1, next 1 and 1 -1 will give you -1. If you add up these two, +1 and -1, this gives you nothing. That means two codes are orthogonal. So this is how we assign different resources to different users. Now coming to the next one, the frame structure. Again, we have also provided the frame structure and information here. So this is the radio frame for the of 10 millisecond for the third generation. Here it is divided. 10 millisecond has been divided into 50 slots, and here you can get the idea of transmission. So okay. So till now we have discussed about the DRAN, distributed RAN. I will let you know what a DRAN is. So we have discussed about RAN perspective, second generation, third generation, first generation, 2.5 generation. What are the enhancements? So I think we have to close our session till here. We will get some basic information regarding these RANs and what a 5G network architecture from a broader perspective in my next lecture. So our second lecture is at 2 to 3:30 in the second half, and my next lecture will be tomorrow at 11 a.m. So we will continue this presentation tomorrow at 11 a.m. Now the house is open for any discussion. If you have any doubt, any query, anything, you can discuss here. Anyone? Yeah, please.
Can you hear me?
Yeah.
Okay. But I know you said we're going to talk about the RAN, for that lecture. But can you just explain the concept of open RAN? It's not
Open
very
RAN, Open RAN is something that comes in 5G. I will discuss. We will continue this discussion in my tomorrow's lecture. Open RAN, 5G RAN we will discuss. Not no not dedicatedly Open RAN, but all the aspects those are covered in 5G. 5G radio access network we will cover tomorrow. So we will continue this lecture. This is half of the lecture, and we have covered so far the aspects related to first G, second G, third generation, fourth generation, and fifth generation. Most of the aspects are yet to be discussed. We will discuss most of the aspects related to 5G tomorrow as well. So I think I will answer all your questions tomorrow. You will get all your answer tomorrow. Okay, this is to be continued. This is half of the lecture. Yeah, any other comment? Query?
Excuse me, sir. It's a general query.
Yeah.
Are we getting these slides after this course?
Yeah, I'll share that. As I promised, I'll try to share most of the content which are delivered here, but that doesn't mean I appreciate you to attend all the classes, because for certification, 80% classes are
That is
necessary.
what I'm asking, sir. Because I'm working as a TRF, Teaching Cum Research Fellow in NSUT.
Yeah.
There are mid-semester exams going. End semester exams are going on.
Yeah.
And I have on alternate days I have some exam duties also.
Yeah.
And these lecture hours are between the working hours. Morning shift will get from 10 to 1, and evening shift will be from 2 to 5. So the lectures are coinciding with my
there are
duties
two
also.
different things. First one is knowledge delivery. Next one is certification. So we are bound to give certificates to the audience, which is being compiled or completed 80% attendance at least. We can relax this up to 75 with the discussion only. But next thing is learning. For the learning, we will provide you the best we could do. We have also requested another experts from Sussex and others, and also MATLAB sessions. We will try to give you all the materials, and if possible, we will try to give you recordings as well. So for learning perspective, we won't leave any stone unturned.
No, sir, that is fine. That I got your point, but I'm just expressing my inability to.
Yes. We can understand. We are also faculty members here. We can understand, but you try your
unintentionally, occasionally I have to, I have to skip the class once or a while.
No issue. We can understand your point. We are faculty. We are also faculty as well. But I request you to give your best.
Yeah, I'll try my best. Meanwhile, in between also, whenever I get time, I will try to join. But in the examination hall, you cannot
I can
go and put your microphone.
We can understand, but one more request, point at each and every point, we would like to have your feedbacks regarding these presentations and the content flow, so that we could provide a better one within the next one also, because we are soon we are planning to have a 2.0 version of the same.
Okay, sure.
Yeah. So I think I have another hand raised. Integrate. Okay, one by one I can take these. Praveen ji. Okay. In mobile network, it shows 5G plus. What is it? Okay, we will discuss it tomorrow, Praveen ji. Okay, next is thank you. Just an appreciation comment. Okay, thank you, Hamza. Next, Sakshi. Okay, next. Thanks for the presentation. Okay, so I think we will give you answer in the next session and in the later sections as well regarding the 5G. 5G, I have included 5G in this slide, but now it would get a bounce on your head. So we will recall something tomorrow, and we will recall a few things, and we will then shift it to the 5G new radio and other aspects as well. And any other hand raise?
Any questions?
So a lot is being planned for. I one comment regarding the integrated sensing and communication. Integrated sensing and communication. We have one expert in this domain, So we have gone through the requisites of all the communication aspects, how these requisitions are being fulfilled, how the standardization come into the picture bit by bit, and release by release, how we are proceeding towards the next evolvement and enhancement. Now, next, we will discuss about more of the aspect related to 5G. In the upcoming sessions, we are having lectures. Okay, so optimization, how to implement can some discussion with. In the evening, we are having one expert in 6G. He is G as well. We have he will discuss about RSMA, which is one of the most promising technique for 6G and beyond. So that be very useful here how to proceed research into it. Next, we have MATLAB sessions to implement such things. Then channel optimization, AI algorithm for channels, and then machine learning. Yeah, so the very first lecture I intentionally put here just to make you understand better, for the betterment of your understanding. Next, we are planning to fulfill or to club these things one by one through the simulation or through the optimization, through the discussion, and what could be the enhanced version of the radio 5G unit as well. So what is coming, what is there for 6G as well. So we will discuss all these things bit by bit. So I request you to have more questions and have patience. Uh, we will let you know what else we could do. Stay connected. Thank you.
Thank you so much for your great lecture, Dr. Rohit. I think Dr. Rohit has covered numerous aspects of 5G communication and beyond that, from starting with a communication network, what are the different kind of releases, starting with first release 1992 to I think 17 up to 2022, and first generation to 5G, and different aspects, what are the different parameters will be available in the 5G and beyond. I think that is a basic is required for this STC, so that you will understand different kind of facts regarding the 5G and beyond communication. So I will also request all the participants be present for an afternoon session. And thank you, Dr. Rohit, for a wonderful lecture. And if any questions are there, you can send the mail, and definitely we'll discuss in the coming sessions. Thank you very much. You can log out your session.
Thank you, Dr. Saab. Thank you.
Thank you, sir. Thank you.